Hello there, Year 8. It's Mr. Parr here. Hope you're all well. This lesson is going to be all about pseudocode algorithms, and it's lesson 2, focusing on sequence. So this lesson is going to be utilised in the workbook. Now, you should have either had a copy at school or accessed this via Go for School. So along with the link for this video, there will be an electronic copy of the workbook, which looks like this. Hopefully you are familiar with it. So space for your name, group and target grade. Target grade, your teacher can tell you that if you don't know that already. And then there's a contents page. So if you do miss any lessons at any particular points, you can go straight back in there. It's also good for revision as well. And just recap, what we've got is loads of different starter activities at the beginning. So you might have already done 1 or 2 of these. So these are for you to complete while you're waiting for your teacher to arrive. Okay, so today we're going to be focusing on something called sequence, and you should be fairly familiar with it. Okay. As you're working at home, if you haven't got a printer, that's fine. You can edit this online, or you could maybe write down your answers on a bit of paper. The idea is this is your workbook to build up and help you to revise from. So, feel free, if you can print it all out. That's great. Otherwise, do it online. As I said, just write it down on paper, and then you can bring it in when we're back at school. But please keep hold of everything so you've got a record of everything. Okay, so let's get cracking on with the lesson. So, so today we're going to look at, we're going to have a quick recap on flowchart algorithms, stuff we did in year 7. And then we're going to use pseudocode to write algorithms that use sequence. Okay, and you should be fairly familiar with what sequence is. And then the challenge of grade 3 is to use different data types in algorithms. Okay, a bit of a recap of what sequence is. I'm going to click on the link to take us to this video. Hopefully the sound will work. Hopefully it shouldn't be too laggy. But if it is, if it doesn't make any sense, just skip ahead 30 seconds and then we'll come back to the PowerPoint. Okay. Let's just check this works. Excellent. Here we go. Okay, so you should be familiar with that video. I think I showed it to most of my classes in year 7 when you were in year 7. So sequence is making sure your instructions are carried out in the right order, one after the other. I always use the example of when I get up in the morning, before I go to work, when I come to school, I wake up, go into the bathroom, I brush my teeth, have a shower, come out, get dressed, get in the car, go to work. Now, some of those things have to be done in the right order. So if I was to get up, get dressed, and then have a shower, I'm going to be very wet. When it comes to actually physically getting when it comes to physically getting dressed, you can put things in a certain order. So you can put your pants on first and then your socks, or you put your socks on first and then your pants. Even though it's a bit weird, it's still okay. But if I put my trousers on first and then my pants, it's quite unhygienic, and also I'm just going to look a bit ridiculous. I'm going to look like Superman. So the order in which you do things are really important too when it comes to solving the problem. Okay, so that is sequence. Let's go back to our, I was going to check to see where we are in our workbook. Okay, so we're now in, we did all the flowcharts last lesson, should have done. So sequence. Okay, so what we can do now, bottom of page 14, it says, what does sequence mean? Okay, and you can just pause the video if you wanted, and you can copy that in. So when the program follows the steps in the correct order. Okay, the other activity on there is a flow diagram. What we need to do is we need to put things in the correct order. Let's read it through. The flow diagram displays an algorithm to calculate the number of ice creams sold each day. It assumes that all ice creams cost the same amount. Complete the flow diagram by dragging, or in which case you can draw a line, or you can actually write it in, the statements on the right to the correct blocks on the diagram. So what you need to do is just draw a line in between where you think each section goes on the flowchart. So Pause the video, draw your lines, whatever you think it goes, and then we'll go through the answers. Okay, so nice and simple. Start. Well, we know start goes at the start, so we go like that. Start goes there. Nice and easy. If you remember, the terminator, start or stop, looks like that. Right, the next thing I'm going to do, I'm going to put my end at the end because that's quite easy. End goes like that. Right then. So now we need to put these things in the right order. So the algorithm calculates the number of ice creams sold each day. Okay, so here we've got number sold equals money collected, the slash means divide by the cost of each one. Now, we can't work this out because we don't know how many have been collected and we don't know the cost of each one. So we can't do that first of all. Can we output the number sold? No, because we haven't worked it out. Okay, so the first thing we have to do is to input the cost of each and the total money collected. So that one goes there. Something wrong with my thing here. Sorry, it's a bit weird. Okay, so once we've input the cost of each and the total money, then we can do the calculation. If you remember, look at that as a parallelogram, which indicates input. So it's going to be an input. This one's a process, and a process is going to be this calculation. Once we've calculated a number sold, then we can output the number sold. Okay, so this indicates when you write an algorithm, the order in which you do the steps is important. So you can't calculate this number sold until we've worked out the cost of each and the total money collected. Okay, so that is a flowchart algorithm which uses sequence. All right. Now, if we were to do this using pseudocode, it would look a bit like this. Okay, so let me talk this through. What we've got here, total money, is something called a variable. I'm going to highlight it. Where's my highlighter? There we go. So total money is a variable. And the way I explain variables, imagine it's like a drawer to store something. Okay, so you want to keep something in a drawer and you need to label the drawer, say what's in it. If you've ever been in my room in A8 in the computer room, I've got loads of drawers and they've got labels on, so I know what's in each drawer. Okay, so think about a variable as being a drawer and it's going to store something. And whatever this is, this word here is the label. So I've got a drawer and I've labeled it total money. Then we have this equal sign, and this is what's called an assignment statement. It means, right, take what's to the right and put it in the drawer to the left in that variable. Okay, in which case, what am I putting in there? Well, I don't know because we have to input it. Okay, and then the stuff in brackets is what is prompted, what displays it to the user. So, for example, enter the total money collected, and let's say I put in £100. That £100 will then be assigned and put in that drawer called total money. Okay, so that's one drawer or one variable. Okay, so my next variable, okay, let's change that to yellow, is called cost. So then I get another drawer and I label it cost. Okay, what's going to go in that drawer? So we have the equals, which is the assignment statement. So enter the cost of each ice cream. So whatever I type in, let's say £1, okay, that goes into that cost. Okay, that variable, £1 goes in there, total money is 100. Okay, then we have a third variable, a third drawer called number sold. That's my label. What's going to go into that? Okay, so this is where we do a bit of a calculation. Okay, so when it says total money, so what it means is go into the drawer called total money, okay, and then divide it by, so we're going to total money, what's in there is 100 in my example. Then it says, right, divided by what's in the drawer total cost. Well, we know I put 1 in there, £1, and then assign the answer into the drawer called total cost. That goes in there. Sorry, number sold. So that assigns the answer and puts it in the drawer, and then print. That just means display. Take what's out of the in that drawer and show everybody number sold. Okay, so that is an algorithm which uses sequence. Okay, it is a pseudocode algorithm because it uses these things called variables and assignment statements. Okay, right then. So here's a little guide to pseudocode. If you want to output something, your program, if you want to display something on the screen, you do that print statement, and then you put stuff in brackets, and then you put the quote marks in if you want to display some text. If you want to take an input from the user, you use input, and then in brackets you say what you prompting the user, what you're asking the user to type in. Okay, so there's an example. Right, any sort of calculations. Addition just uses the plus symbol, nice and easy. Subtraction, use the minus symbol. Now for multiplying, you actually use the star symbol. Now, if you're not too sure why, think about it. On a keyboard, if you use an X, that could be confused with the letter X. Okay, so instead we use the star symbol. And if you're using a computer now and it's got a number pad on the right hand side, you should see around the top right hand side of that number pad we have the plus, minus, then you see the star button. That means multiply. And the next one you can see is a slash there. That means divide. And we use a slash because there's not the divide symbol easy to hand on a keyboard. So those are the symbols we use in our pseudocode as well. Okay, so key things you need to remember is star for multiply, slash for divide. Right. So I'm going to have a go at writing this. I know the answer is on your page, but I just want to talk it through as well. So on page 15 is an example algorithm. So normally you're presented with a problem, and then you have to write it using pseudocode. It says, write an algorithm using pseudocode that asks the user to enter 3 numbers. I'm going to stop there and do that first of all. So the user's got to type in 3 different numbers. So I'm going to need 3 different drawers to save it, or 3 different variables. Okay, so first of all, we do num. I'm going to call it num1. Notice I haven't got any spaces in variable names. So num1 is equal input enter first number. I do apologize for the state of my handwriting, but using Teams, it's all gone a bit weird. Okay, num1 equals input enter first number. There's my first. I've got my tray. I've labeled it num1, and I want someone to type in their first number. Now I need another number, so I need a separate tray, separate variable. Oops, sorry. So num2 equals input and a second number. Ooh. So remember, that's an assignment statement. So they're going to input it and goes into that tray. And then num3 equals input enter third number. There we go. So I've just done the first part of this. I've written an algorithm using pseudocode that asks the user to enter in 3 numbers. I've done that. Enter first number, enter second number, enter third number. 3 different trays, 3 different variables. The program then displays the sum of the 3 numbers. In other words, it adds them all up. So whenever we do an algorithm, we need an extra tray to store our result. So I'm going to call it, I could call it sum. In this case, I'm going to call it total. Total is going to be, well, how do we work it out? We need to go into tray 1. So it's going to be num1 plus num2 plus, sorry, num3. Okay, so what it does, it takes what's inside tray 1, adds it to what's inside tray 2, adds what's inside tray 3, adds it all together, and then the result it puts in the variable total. Have I finished? Not quite. I need to display it. So then I just print total. So that means it's going to go into my tray called total and then display the answer on the screen. Okay, so I understand that's the same as exactly what's in front of you, but I think it's sometimes really useful to talk through an algorithm as you're writing it, and there's a much neater one than my rubbish scribble. Okay, so your job on page 16. Let's have a look at it. So let's go to page 16. Okay, there's your example I've just done, blah, blah, blah. It says, write an algorithm in pseudocode that calculates the area of a rectangle. The algorithm should ask the user to enter in the length, ask the user into the width, calculate the area of the rectangle, and then display the area of the rectangle. Okay, so think about what variables you're going to need. Okay, think about how you do the calculation. I'll help you out with it. Okay, and the challenge as well is to add to the end of the algorithm, oops, so it calculates and displays the perimeter. Okay, so that is your job, ladies and gents. That is all I need you to do for this lesson. So to help you out, okay, if you didn't know that the area of a rectangle is the length times the width. Okay, if you need that. Right, so what I'm going to do is I'm going to do a gapped version on the screen for you. What I suggest you do is pause the video, have a go yourself. If you get stuck, unpause it, look at my gap version, have a go and fill in the gaps, okay? And then what I'll do is I'll go through the answer as well as the challenge, okay? Good luck. Pause the video, don't cheat. Okay, I'm going to do a gapped version. I'm not going to talk it through, but you can have a go if you need it. So I'm trying to be as neat as possible. I do apologise. Okay, so there's your gapped version if you're a bit stuck. Okay, I'm going to fill the gaps in just a minute. So pause the video. Okay, let's go through the answer. Oops, oh, didn't want that to happen. Okay, let's change my colour to blue. So what we've got here is, let's go back to our, it says asks the user enter in the length. So here I've got something equals input enter length. So remember, this is our variable, our tray. What should we call it? Well, it's going to store the length. So let's call it length. You could call it L, you could call it Dave, or you could call it whatever you wanted, but I recommend your variables are relevant to what you're storing. It's like if I had a drawer full, if I in my room I have like a label for pencils. I open a drawer, got pencils in there. It wouldn't make sense if it said like Dave. Okay, what's in there? It wouldn't be full of Daves, it would be full of something else. So if that makes sense. Okay, so we have a variable called length equals input enter length. So sure enough, something equals input enter width. It's going to be width. Okay. So if I go back to this, I've done the first bit. I've asked the user to enter in the length. I've asked the user to enter in the width. I now need to calculate the area. Well, you can see there, area is length times width. So I've got here. So I need a tray or a variable to store my answer. I'm going to call it area is equal to length times width. Now it's really important. These variable names here match what you called them here. So if, for example, you called at height and that says width, that's a different tray. So it's got to match. And then finally, print area. Okay, simple as that. So I've done that. It calculates the area and then displays it. Let's have a look at the challenge. Add to the algorithm so it calculates and displays the perimeter of a rectangle. So there's a couple of ways of doing this. Okay, so if you remember a perimeter, oops, yeah, go away. Keep. Oops. Let's go back on. So if you remember, a perimeter is basically the length going all the way around. So you need to add the two lengths and the two widths. So there's two ways of doing it. Let's choose a purple color, I think. So now, because we've already typed in the length and the width, we don't need to do that again. So we can just carry on below. We've already got that information. So perimeter, because I need a new variable to store my answer, is equal to. Now we could do this way. Length plus length plus width plus width. That's nice and easy because we've got length, length plus width, width. That's that. And then I'll just print perimeter. That's it. That's one way of doing it. I know some of you might have come up with an alternative. So let's draw a little line here to show a different way of doing it. So you could have had perimeter is equal to 2 times length plus 2 times width. Okay. Or I'll do it the wrong way. Perimeter is equal to, I know some people might have done this, 2 times length plus width. So what's wrong with that? Okay, now the wrong with that is BIDMAS. Brackets, indices, division, multiplication, addition, subtraction. It does it in that order of priority. So what would happen here, it would multiply the length by 2 and then just add on 1 width. Okay, so what you would have to do is put some brackets in like that. Okay, so there you go. So that is sequence using pseudocode to write algorithms. We've introduced the concept of variables to store our data as well, and also our arithmetic operators, multiplication, division, addition and subtraction, and also what's called the assignment operator, that's an equal sign. Okay. I think that is about it. Apologies for my terrible handwriting. And the next video is going to focus on selection. Any questions, please email your teacher or email me directly, tpart@dormston.dudley, and you know the rest. Okay, thank you for listening. I'm just going to come out of this and I'm going to end the recording. Okay, take care.